Good day, everyone. And once again, we're back together. And this time, we are once again looking at vectors in 2D. We've already started with this problem in the previous video, but I wanted to actually just tackle it in a different manner using vector components. So if you haven't subscribed, please just make sure that you're part of the family. And of course, you can always reach us for our value-added services. If you want to know about our tutorials, our classes, for those that are upgrading and those that need additional assistance, our email address is info@mlungisinkosi.co.za. All right, now let's get right into the thick of things. Right, so we've already looked at this problem. They said to us we've got a 250 kilogram engine of a car that is suspended, that is, it's held stationary by two ropes that are tied to the ceiling of a house. So T1 makes an angle of 40 degrees. Okay, so I'm assuming this would be T1 and that would be T2. Okay, so and T2 makes an angle of 20 degrees. If the engine is held in a stationary position, I guess it's worth repeating. Answer the questions that follow. All right, now, ladies and gents, we've already looked at it, looking at using the sine rule, okay, using the triangular law of vectors or forces in equilibrium. So in this case, what I want to do, if you'll allow me, I'll just answer question 1 and question 3 without necessarily stating question 2. So they say draw a free body diagram. Now remember, whenever you draw a free body diagram, okay, please use that dot, and that dot signifies or represents the center of gravity of the object. Okay, so we know we've got T1, okay, and T1 makes an angle of 40 degrees with the horizontal, and we also have T2, okay, that makes an angle of 20 degrees with the horizontal. So this would be the force on T1, the force on T2 rather. The force, let's say this is the force on tension 1, or you can call it just tension 1 and the other one tension 2. But we also know that the gravitational acceleration, or rather gravitational force rather, always exerts a force, or the earth exerts a force on the object. We call that the force of gravity, okay, or we can call that the weight. Sorry for writing that in an ugly way, right? Or we can call it the weight, right? Now, we had calculated the weight in the previous video. We said, well, weight, that's mass times gravitational acceleration. Remember, that's a constant value. Some of you may use 10, but I prefer using 9.8. So if you prefer using 10, there's nothing wrong with that. So we said this is going to be 250 multiplied by 9.8, and if I remember, we got 2450 newtons, right? So those are all the forces that are acting on the body. Now, let's calculate now, determine the, either by scale drawing or calculation, the magnitude of T1 and T2. Now, how are we going to calculate that? Now, ladies and gents, what I'm going to do is use now vector components, right? So it means that T1 would have a horizontal component in that direction, right? I'm going to draw that in red. Okay, so there is, I'm going to call it T1x, all right? But similarly, it means that T2 has got a horizontal component. Okay, let me just try to fix that. Okay, so it's got a horizontal component in this case. That is also acting in that direction, right? For some odd reason, I'm not getting this right. You know what? I'm just going to, if it doesn't work, I'll just leave it in that as it is. Okay, so we said, okay, there we go. So we said T2 is also has a horizontal component, right? So I'm gonna draw it there. Okay, So there's the component of T2. Right. But remember that we also have a vertical component, right? So in this case, there's our vertical component of T1. I'm going to call that T1y. And of course, we've got another vertical component of T2, and I'm going to call that T2y. Now, ladies and gents, let's just talk a little bit about these components as well as the calculation that goes with it. Now, remember, so what happens is that, remember that we've got, okay, so if we look at that horizontal line and that 20-degree, angle there, right? That if you think about it, this line here would therefore be parallel with that line. And so what does that mean? It means the angle here would actually form a 20-degree angle because of alternating angles, right? Alternating angles between parallel lines. But the same is true here. So we've got 40 degrees, okay, over there. So what does that mean? It means that the angle inside here would actually be also 40 degrees, because remember that that is parallel to that in this case. So therefore alternating angles would be actually applicable. Right. Now, in this case, I want you to please note this, right? So it means if I were to look for, let me just try to do that. So if I'm looking for T1x, right? I want you to think about it. If you look within this triangle, let me just try to remove that. If I look within this triangle, remember, if I want T1x, this is adjacent to that 40-degree angle, right? And in this case, remember, we are interested in finding T1, which is the hypotenuse. So I'm going to use my trig ratio and say, well, adjacent over hypotenuse, that's the cos, right? So it means that T1x would be T1x is equal to T1, the cos of 40 degrees. Now, if you don't know where this comes from, it means that you might have missed the video that I did where I was talking about the introduction of the section. Please just go back and look at that video, right? So where this simply comes from is that the cos of the angle, right, would be adjacent. This would be the adjacent side in the hypotenuse, okay? So in that case, it simply means that the cos of 40 degrees would be equal to T1x adjacent over the hypotenuse, which is T1, okay? So if I cross multiply, right, therefore T1x would be equal to T1 cos of 40. All right, so I hope that you understand that. So similarly, it means T2x would be equal to T2 the cos of 20 degrees. So these are our horizontal components of the forces. So these are the ones in red over there, right? And perhaps it would have helped if I had written them in red. Okay, so now let's talk about the green, the vertical components, right? T2y as well as T1y. So it means to get those, we're going to say the sine of the angle y, the sine, because in this case it's opposite over hypotenuse, right? So that's going to be opposite over hypotenuse. I hope that makes sense. So the sine of, let's start with T1, the sine of 40 degrees would be equal to T1 x, right? Opposite, that's T1x, T1y rather, T1y over hypotenuse, which is T1. And so again, if we cross multiply, we know that T1y would be equal to T1, the sine of 40 degrees. Okay, so I'm going to, just as a reminder, so these are the vertical components, right? The ones in green, right? So again, the same thing is true with T2 rather, T2y would be T2, the sine of 20 degrees, right? So that is how we will get our vertical components. Right, now I want us to do the following. Let's just simply look at the forces, okay, in red, right? So we know that we've got the forces that are acting horizontally. So we know that our horizontal forces would be T2y acting in that direction, and it would be, T2x rather, T2x acting in that direction, as well as T1x acting in the opposite direction. And I'm not suggesting in any way that they're equal, all right? One of them probably is bigger than the other, right? But now, because these are the only two forces that are acting horizontally, right? So remember, what are we doing? We are only taking horizontal forces. We are replacing these forces here that were acting at an angle, right? We are now reducing them into their respective components, right? So now it means that if we were to take the sum of forces, right? So the sum of forces in the horizontal direction, okay, that's net force. We know that it's going to be equal to 0. Why? Because our system is at equilibrium. Please remember that equilibrium of forces, right, simply means that we have got a 0 resultant, right? So now I'm going to just take, and it doesn't matter which one you take as positive. Let's take direction to the right as positive. So it means that I'm going to say T1x plus a negative T2x. These are equal to 0. Now T1x, remember we said this is T1, the cos of 40, minus T2, the cos of 20, and this is equal to 0, right? So let's just find a way to represent one of them. So T1 cos 40 is equal to T2 cos 20, and of course we can divide by cos of 40 on either side. So that's cos of 40, and so T1 would be equal to T2, the cos of 20 over the cos of 40. Right, I'm going to leave it in that manner. Now let's look at the forces that are acting vertically, right? So remember, we've got T1y, okay, so we've got T1y, okay, we've got T1y acting vertically upwards, T1y, and we also have T2y. I'm assuming T2y would be smaller because it has a smaller angle, right? T2y. And in this case, remember, we also have the gravitational force that acts vertically downwards. Those are all the forces that are acting downwards. And we said this is 2450 newtons, right? So now we can say, well, supposing that we're taking upwards as positive, and it really doesn't matter this time, because our system is at equilibrium, right? So we're going to say F net, which is equal to 0. The net force, the sum of forces, is equal to 0. But this time we're taking the sum of forces in the vertical direction. We say this is equal to 0. So that means in this case, now note, both forces are acting upwards. So it means T1y plus T2y minus the weight, or we can say the force of gravity, all of that is equal to 0. So we know this is going to be T1, the sine of 40, plus T2, the sine of 20, right? We've already established that. All of these are equal to, I'm taking the weight to the other side, and so it becomes positive 2450. Okay, now, ladies and gents, if I can leave this as equation 1, then it means I can call this equation 2, right? And so what can I do? We need to solve this simultaneously. So I can say substitute equation 1 into equation 2, right? So it means where I see T1, I am going to actually substitute it with T2 cos of 20 over cos 40, right? So T1, right? We said we are substituting, right? So remember we said T1 is T2 cos 20 over cos 40, right? So this is going to be T2 cos 20 over cos 40. So we are substituting that T1 there. But remember, it's multiplied by the sine of 40. Okay. Plus T2 sine 20. This is equal to 2450, right? So now we've eliminated one of the variables, right? Now let's just make that into one thing. Sine 40 over cos 40, that's 1040. But what I'm going to do is let's do this. So if you look at this and that, both of them are terms that have T2 in them. So if we take T2 as the subject of the formula, so that will be cos 20 over, in fact, let me rather make it simpler for myself, because sine of 40, sorry about that, sine of 40 over cos of 40 is 1040. So this would be cos of 20, 1040, plus, remember we've taken out T2 as the subject of the formula. This is going to be sine of 20. Okay? And this is equal to 2450, right? Now, all that's left for us to do, what I'm going to do is just divide by that whole thing in this case. But what I do on the left, of course, I'm going to do on the right, okay? Because I'm out of space here, maybe let's get a value for it, right? So we've got cos 20. So that's cos 20, 1040. And you can do this however you like, right? If you still wanted to have sine over cos, that's still fine. Plus, in this case, sine 20. That's sine of 20. Okay, so that gives me 1.13. If you want to, what you can do is just simply take that value. Okay, and what I'm going to do is divide 2450 over that value. So I'm going to say divide by 2450, right? But what I need to do is invert that value, right? Oh no, I think I made a mistake. That's 1.13. Okay, right. So I'm going to just say 2450 divided by 1.13. Sorry, ladies and gents, because I lost that value there. So my T1, rather my T, is it T2? Yes, that's T2. That's going to be equal to 2168.14. Now, those who've watched the previous video, you'll see how closely these values are related with the answers that we got previously. Now, how do I get T1? So I'm going to substitute T2 equals to 2168.14 into my equation 1. Remember my equation 1, right? This one. So T1 is T2 cos 20 over cos 40. Okay. T1 is equal to T2 cos 20 over cos of 40. And so I'm going to put that value 2168.14 cos 20 over cos of 40, right? Okay, so let me take that value, multiply it. So let's do this. Okay, I'm going to multiply the answer by cos of 20, and I divide that by cos of 40. Okay, there's that value again. Okay, 2659.62 newtons. It may not exactly be the value that you got in this case, but you'll see that it's pretty close, right? That's because I rounded off before time. But in this case, this is how we are going to use components instead of using the triangular law of vectors in equilibrium. Ladies and gents, I hope that you understood this. Of course, it's a little bit involving mathematically, but nonetheless, it does do the trick. I hope that you enjoyed that, and please don't forget to subscribe, to like, to share, tell them that your favorite uncle is doing the most. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.